Hi, it's Tony Fong here again. I can't believe it's 5 months since I last did a video. I just really don't know where the time goes. I expect you have the same problems. Anyway, the video I'm doing today is about making clamps to clamp onto some sort of cylindrical object. For instance, this is a clamp that I made to hold this high-speed spindle for doing some internal grinding or similar work. This is another one. This one's made in steel, and this one clamps onto the quill of a Bridgeport mill, and we're going to look at why this was a very bad. And this was one that also clamped onto the quill of the same Bridgeport mill, but with a second hole which was also to take a high-speed spindle. So we're going to look at why this one's so much better for clamping, and then we're going to look at how I made this one and the particular features of this which combine both of these two clamps. We'll see why these clamp so much better. Well, this is what got me started on some clamp making. This mill is a Bridgeport. From new, it was fitted with a CNC system. Mechanical parts on it were quite nice, except for this clamp. This is the ball screw which powers the quill up and down in the Z axis. That's fitted into a slot in the end of this clamp, and then the clamp goes around the quill. I made an additional clamp which sits on top of that one to hold a high-speed spindle. This will spin up to 24,000 RPM. I've moved this spindle clamp up a bit, basically so that we can just see one of the faults in the manufacture of this particular clamp. At the moment it's just held on by the bolt which holds it to the ball screw. So I'll just loosen that, and now we can see one of the problems. The bore in here was made way too large. In fact, it's about 0.2 of a millimetre, 1/8 thou difference on a diameter, which is much too much when you want to fit something like this, particularly when it's made in steel and it's this thick, because it takes a lot of force to actually clamp that on. But then when you clamp that on, it'll be touching at the two opposite sides here, but you'll still have that gap at either end here, and that's the direction in which you want some stiffness. Pretty bad. So we've seen the fault in manufacture of this piece, in that the hole was bored way too large. In fact, there's a double diameter on the end of the quill. There's this screwed on piece at the bottom, and then you've got the quill itself, and this is a touch smaller. This was actually bored with two diameters, but the small diameter is even so large that it would fit up over the quill itself, which was a larger diameter. It was quite bad. But in addition to this fault with manufacture making this too big, there is also a design fault. Now, bear in mind it's an inch thick, or 25.4 millimeters thick, which is pretty thick for some steel. I've milled this down. The original was as the yellow piece of cardboard, so you can now see this is much thicker across here, and this slot only went back to this line. I drilled that hole and extended the slot to give some more flexibility. This was so stiff across here that it didn't matter how much I tightened the clamping bolt, it made no noticeable difference to the compression of this, or the clamping force that was provided. Basically it all had to be done by the bolt through this end to provide all the clamping. This area around here was the only part that had sufficient flex in it to do the job. Well, we've seen the reasons why this commercially made clamp, the clamp that was actually made for the CNC setup, was particularly bad, and why I needed to modify it. So, having learnt the lessons from this particularly badly made clamp, let's see how we can take those lessons and make a better one. This is the clamp that I made to take the high-speed spindle. This has been bored size for size with the quill. This is concentric and relatively thin, more than half of its circumference, so it can flex quite a bit there and conform to the shape of the quill. And again, this has been bored size for size for the outer diameter of the high-speed spindle. You can see just how easy it is to clamp this up, because I can squash that, cause significant clamping, just by the pressure of some fingers and my thumb. You can see the gap closing up here and here. Normally something that's size for size, we'd be struggling to fit it up. As you can see, it's starting to go, but it's not easy. Because of the flexibility here, I can just open it up a little bit, slip it on quite easily, and you can see that it's pretty firm without even doing any clamping. So now I would put the high-speed spindle in here and tighten these two clamping bolts, and it would be extremely tightly held on the quill, and also it would hold the high-speed spindle very rigidly. This is a clamp that I made to hold a high-speed spindle in the lathe. It's got dovecot tails cut here so that it fits onto a quick change tool post. Again, following the same principles, this is quite flexible, but it's been done for roughly half of its circumference or so. It's been thinned down so it's got an area to flex. This bulky bit here doesn't matter too much, because this single clamping bolt doesn't have much leverage on the material in this region, so if that's thinned down, it's not going to make very much difference to the performance of the clamp. Most of the flexing will be taking part back here, and you notice how I've necked this in to allow a much greater length on each side for the flex. If I continue that on straight, you'd see it'll be much harder to get that easy clamping force, which makes such a difference. This is a clamp that I've made to replace the two other ones. You can see it's quite thick, which will give a lot of location onto the quill, and also locate the high-speed spindle very rigidly. And because this is aluminium, end of the ball screw might well over time dig into this, so I've put a stainless steel slotted bush in this end that the ball screw fits into to stop the Brunelling of the aluminium. We'll look in more detail how I made this and the various reasoning behind it, all the features. Well, this was the piece of old tooling that I had. You can see there are numerous holes in there, and so it was a little bit difficult to find somewhere that I could cut it out without any holes through the middle of it. But over on this side, I did manage to find an orientation that all of the holes came inside where I was going to bore. One hole here, so what I did, I put the slot aligned with that rather than aligned with this slot through the bores. You know, it doesn't matter with it being that far off. And there was just another little hole that you can probably see here, because there are a few holes that are drilled in the side of this plate. So I did all right. I've still got quite a lot of good plate left for another project. The plate was 40mm thick, which is a bit thicker than I wanted. I ended up machining it down to what I'd planned, which was 35mm.
The plate is on the bandsaw now to just roughly cut out the shape. This shows how I managed to orientate the shape that I wanted to avoid most of the holes.
Okay, well, I've got the bandsawing finished. It's not looking shape, but you can see how it fits up. This was the clamp to move the Z-axis on the mill. As you can see, what I've cut out replicates that. I need to bore a hole in the centre there, and the other side, sharing the same hole, replicates the piece that holds the high-speed spindle. The marked lines indicate roughly where I'm going to mill this out. Now I've narrowed this down a little bit so that it gives much more of a concentric piece coming around here that's got a little bit of flex in it, which will help ensure a good clamp onto the quill of the milling machine, and on here it will ensure a good clamp onto the hole for the high-speed spindle. I could just simply bore it away and make a lot of swarf, but I happen to have a couple of hole saws that weren't too far off, so I'll cut this out with this hole saw, then it won't leave very much more to bore out, and then I've got a smaller hole saw that will do for this hole. The scrub block of aluminium that I cut this from had various pieces milled down. That's not going to be a problem because for most of this it's 40 millimeters thick at the moment, but I'm going to take it. The original clamp for moving the Z-axis is actually 25, but that was in steel. This is in aluminium. It's a little bit more flexible. I didn't want to make it too tall because otherwise I won't be saving very much on the height of the two of those together, and that was the prime motivation for making this one-piece clamp, was to reduce the total thickness, because that reduces the quill movement. You may have noticed when I was doing the original band sawing that I kept daubing on this waxy type stuff. It was called cutty stick lubricant. When I was doing the cutting and pushing the material through, sometimes I could feel that it was taking a little bit more force, so I just put some of this onto the blade, just let the blade rub on it to pick some up, and instantly it would start cutting faster and easier. I can't remember where I got it from, some tool shop in America at one time a few years back, but it's really good stuff for doing something like this. Also for when you're tapping threads, it's quite useful because it stays in place better than some of the liquid cutting fluids. While we're doing a bit of hole sawing, I'm doing a drill press rather than the mill, just simply for speed and convenience. Here we go. Well, it's probably pretty boring to watch the rest of that go through, so I'll end it here. Okay, well here's the block now. I've faced it off. It's 35 millimeters thick, which is what I've decided I'm going to keep it at, and I've put a hole saw down to cut these plugs out, so now it's ready to bore out to the appropriate size. Well, I'm just about to take the finishing cut on the clamp. I could do it by circular interpolation using the CNC features of the mill, but when I'm doing a hole like this and I want it a very precise diameter and a nice circular and surface finish, I much prefer to use a boring head. I've got here a very nice Narix head, and it's an absolute beautiful piece of kit. It's a really lovely thing to use, so that's what and away we go. So here we are cutting out the profile. Okay, now I'm cutting the slot which will enable the clamp to do its clamping. I've got a thin slitting saw mounted in the mill, just taking small cuts. Well, it'd be boring to watch anymore. Okay, so now I'm going to bore a hole in here. It'll only go about halfway down. That's for the stainless steel insert, which will take the end of the ball screw for the Z direction. Here we're turning the stainless steel insert block, which will go into the aluminium clamp. Right, well now I'm milling a slot in the stainless steel insert The slot allows the end of the ball screw, a tang on the end of the ball screw to fit in, and being a slot it prevents it from rotating.
And here's the finished bush. And the bush fitted into the end of the clamp, ready for use.
Well, here we are, the finished bracket mounted up, the high-speed spindle mounted in it as well. You can, I'm pushing as hard as I can, there's just no movement in it at all, it's very, very rigid. Now, this is where the ball screw is to give the Z-axis feed when it's used in CNC mode, but I still use the mill in manual mode, and so I've added this handle onto the bottom of the motor so I can still use it in a manual mode with this. At the flick of a switch I can change the control method from the manual handle that we've just seen to the full CNC system, or just this jogging control on the control panel. Well, we've seen the problems that we have with the original clamp and various things that we can do to make much better clamps. So to summarize, basically we need a good fit. The bore needs to not have too much clearance on the spindle or whatever cylindrical object it's going on, and we also need some degree of flexibility to allow the clamp to conform as much as possible to the cylindrical object. The ultimate in flexibility is provided by a thin strap like this, taking things to extreme. As you can see, that will wrap around and conform exactly to the shape of the object that we want to clamp. You can't do better than that. Well, that's it for this video. If you have found it useful, interesting, please subscribe to my channel and click on the like button. Thank you very much for watching.